they say there is a cone with the base radius 15 cm and the height is 36. And then finally, we cut it by two parallel planes to the original base, such that the heights of 3 parts are equal. That means each section is 12. Now we are going to use the ratio approach to solve this problem. We label those 3 parts by the first part, second part, and the third part, so you know which region we are talking about. And we can find some similar shape here, which is very useful. So rather than compare part by part, we try to compare the smallest cone similar to the middle cone, similar to the largest cone. If we use the part, this is just the first part, while this one is first together with second. And this is the first plus second plus the third one. One thing very important is we know that this one is 12. The height here is 24 and the height here is 36. So we know the length ratio. This is called L1 because talking about the first part. To L, not 2 but 1 plus 2. To L, 1 plus 2 plus 3 all together is equal to 12 to 24 to 36. In short, that means 1 to 2 to 3, both all region divided by 12. After that, we are talking about the volume, so we can get the volume easily. Volume ratio 1 plus 2 to volume 1 plus 2 plus 3 is equal to cubic of that. So this is 1 power 3 to 2 power 3 to 3 power 3. We get 1 to 8 to 27 within a very short time. So if you let this volume is 1 unit, let's say 1K, and then the second volume V1 plus V2 is equal to 8K. V1 plus V2 plus V3 is equal to 27K. If you separate to 3 regions, okay, the first region is equal to 1K. The middle region, the second part, is equal to, originally we have 8K, we remove the first one, which is equal to 7K. Finally, the third region is equal to the total 27K, and then we subtract these two together, then we subtract 8 minus 8K, we have 19K. So if we ask the volume of the first part to second part to third part is 1 to 7 to 19. That's how we distribute the volume. V1 is equal to, now we calculate the volume of the first one. From 36 to 12, we divide by 3, so the radius is equal to 15 divided by 3 also. And then we apply a volume formula of a cone is 1 over 3 pi base radius squared times the height. Base radius is 15 over 3. And then the height of this smallest cone is 12. We get 100 pi cm cubed. Therefore, since we already know that the second part is 7K, V2 is equal to 7 times of V1, so it's equal to 7 times 100 pi, which is equal to 700 pi cm squared cube. In part B is basically the same. We are asking for the curved surface area is equal to S2 minus S1. So we know S1 to S1 plus 2 to S1 plus 2 to 3 is equal to 1 square to 2 square to 3 square. So we have 1 to 4 to 9. Therefore, S1 to S2 is equal to 1 to 4 pieces, deduct 1, 3. And then for the curved surface area, and then we start calculating from S1 here. S1 is equal to pi r L, refer to the smallest cone. Then we hit the height is 12 while the base radius is 5. The slant height by Pythagoras theorem, we know that is square root 12 square plus 5 square. So is pi r is 5 while L is square root 12 square plus 5 square, which is 13. So we have 65 pi. In order to get S2, because we know how they are related already, therefore S2 is equal to 3 times of S1. 3 times 65 pi, we get 195 pi cm square. In this question, I didn't write clearly what is this label mean, so you need to copy exactly the same thing. Volume of middle part of the circular cone. The curved surface area of the middle part.